What's up for November? Sunset planets, a partial lunar eclipse, and the return of the winter stars. From November 6th through the 11th, watch the moon glide past Venus, Saturn, and Jupiter after sunset in the south-southwest. In particular, if you step outside for a look on November 7th, you'll find the 4-day-old crescent moon just about 2 degrees away from Venus. Should be really pretty, so don't miss it. And now through early December, you'll find Jupiter and Saturn drawing a little closer to Venus each night. A partial lunar eclipse is on the way, taking place overnight on November 18th and 19th, when the moon slips into Earth's shadow for a couple of hours. Weather permitting, the eclipse will be visible from any location where the moon appears above the horizon during the eclipse. Depending on your time zone, it'll occur earlier or later in the evening for you. Now that's a huge swath of the planet that'll be able to see at least part of the eclipse, including North and South America, Eastern Asia, Australia, and the Pacific region. So check the timing of its visibility for your area. For U.S. East Coast observers, the partial eclipse begins a little after 2 a.m., reaching its maximum at 4 in the morning. For observers on the West Coast, that translates to beginning just after 11 p.m. with a maximum at 1 a.m. Partial lunar eclipses might not be quite as spectacular as total lunar eclipses, where the moon is completely covered in Earth's shadow, but they occur more frequently. And that just means more opportunities to witness little changes in our solar system that sometimes occur right before our eyes. All month long, if you're up late and cast your gaze toward the east, you'll notice some familiar companions have begun rising late in the night. The familiar stars of northern winter skies are returning, rising late at night and sitting high in the south by dawn. You'll find the Pleiades star cluster leading the constellations Taurus, the Bull, and the Hunter, Orion, followed by the brightest star in the sky, Sirius. All of them back to keep us company on the long winter nights here in the northern hemisphere. And for those in the southern hemisphere, they're keeping you company on shorter nights as spring gives way to summer there. A fun note about the Pleiades this month is that several of the 8 asteroids to be visited by NASA's Lucy mission are located in that part of the sky. The Lucy spacecraft launched on October 16th on its 12-year mission to visit a bunch of special asteroids called the Trojans. They share the orbit of Jupiter, with a group of them leading the planet and another group following behind it. Lucy will be the first space mission to explore this unique group of asteroids, providing new insights about the formation and early history of our solar system. Here are the phases of the moon for November. You can catch up on all of NASA's missions to explore the solar system and beyond at nasa.gov. I'm Preston Dykes from NASA's Jet Propulsion Laboratory, and that's what's up for this month.
When you think of NASA, you probably think of astronauts, satellites, Mars rovers, and telescopes that study distant planets and far-off galaxies. So why does NASA as a space agency study Earth? Because it's a planet too, and there are a lot of advantages to monitoring the only home we currently have, from space. Just 3 years after the space age began, NASA launched the first satellite to monitor Earth's weather. It was the beginning of a revolution in weather forecasting and laid the foundation for the global study of Earth. Today, NASA's fleet of Earth-observing satellites is essential to helping us understand how our planet works. We're trying to answer some very big questions. How is Earth changing? What's causing these changes? And what does the future hold? The answers are critical to human life and civilization as we know it. Adding to what we learn from satellites, NASA also makes regional observations from airplanes and ships. Our scientists collect even more data on the ground, and others use computers to model what's happening now and in the future with the land, ocean, and atmosphere. Altogether, it's called Earth System Science, and NASA is a global leader in the field. Best of all, NASA shares what it learns with researchers and agencies throughout the world. Because when it comes to understanding Earth, space is the place to really know a planet. And that's exactly where NASA is.
we're already feeling the effects of climate change. Intense heat waves, longer fire seasons, droughts, and floods. The impacts of a warmer planet are all around us. And as global temperatures continue to rise, we'll experience even more changes to our planet. New NASA research suggests that with high greenhouse gas emissions, we'll see declines in global crop yields for maize, corn, as early as 2030. Shifting rainfall patterns, higher temperatures, and increased atmospheric carbon levels are likely to affect where and how much of staple crops like corn, soybeans, wheat, and rice can be grown. Using multiple highly accurate supercomputer models, researchers projected future global conditions based on greenhouse gas emissions. They ran these results through models that simulate how crops respond to changes in things like rainfall, temperatures, and atmospheric carbon dioxide. By using multiple computer models, the teams could compare results and be more confident in what they learned. Overall, corn and wheat showed the clearest results. By 2069 through 2099, global corn crop yields could decrease 24%. Corn is grown around the world, with large quantities grown in countries close to the equator. Rising temperatures in this region will put stress on those plants, leading to lower crop yields. Wheat, on the other hand, grows mostly in more temperate regions, like the northern US and Canada, North China Plains, Central Asia, Southern Australia, Europe, and Russia. Warmer global temperatures and higher atmospheric carbon dioxide could increase wheat crop yields up to 17%. However, these increases will likely level off by 2050 or so. Changes to our global agriculture are likely to happen relatively soon, even in scenarios where we significantly lower greenhouse gas emissions. The more we understand about how our global food systems will change in a warmer climate, the better prepared we can be.